Okay, inert pair effect increases from top to bottom. A stability of oxidation state plus 2 increases and that of the plus 4 decreases from carbon to lead. This is the carbon, silicon, germanium, stannum, lead. In case of the plus 2 carbon, silicon, stannum. In general, carbon, silicon, germanium, tin shows oxidation plus 4, while the lead shows plus 2. Inert pair effect and oxidation state of group 14 elements. The inert pair effect increases down the group 14 from carbon to lead. As a result, the stability of the plus 2 oxidation state increases, whereas the stability of the plus 4 oxidation state decreases from carbon to lead. Stability of the plus 4 oxidation state, carbon, silicon, germanium, tin, and lead. The decreasing stability of plus 4 oxidation state is due to the increasing reluctance of the ns2 electrons paired to participate in bonding. Consequently, the energy required to excite these electrons increases down the group. Stability of the plus 2 oxidation state. The plus 2 oxidation state becomes progressively more stable down the group because the ns2 electrons pair remains inert and is not involved in the bond formation. In general, carbon, silicon, germanium, and tin predominantly exhibit the plus 4 oxidation state, whereas the lead mainly shows the plus 2 oxidation state due to the strong inert pair effect. What is the inert pair effect? Unexplained lead plus 4 is oxidizing agent and lead plus 2 is not. The inert pair effect is a significant phenomenon in organic chemistry, particularly for the heavier p-block elements. The inert pair effect refers to the reluctance of the outermost s electrons to participate in chemical bonding due to poor shielding by the intervening DNA of orbitals. As we move down the group in group 13 and 14, the ns2 electrons becomes increasingly inert. This happens because poor shielding, the DNA of electrons do not shield the nuclear charge effectively. Nuclear attraction, the ns2 electrons experience a stronger pull from a nucleus, making them harder to remove or share energy costs. The energy required to unpair these electrons and promote one to the orbital is not sufficiently compensated by the energy release during bonding formation is higher oxidation state. We can ask also a question, why lead plus 4 in oxidizing agent and lead plus 2 is not. Lead plus 2 is the heaviest stable member of group 40 with the valence electronic configuration 6s2 6b2. Stability of configuration states due to the inert pair effect. The stability of lower oxidation state increases down the group while the stability of higher oxidation state decreases. Lead plus 2 is very stable because the 6s2 electrons remains inert and paired. Lead plus 4 highly unstable and strongly wants to return to the more stable plus 2 state. Oxidizing behavior. An oxidizing agent is a substance that gains electrons, gets reduced because lead plus 4 is unstable. It radially accepts 2 electrons to reach the stable Pb plus 2 state. Since Pb plus 4 is the eager to pull the electrons from other substance, it acts as a powerful oxidizing agent. While lead plus 2 is not an oxidizing agent, lead plus 2 is already in its most stable configuration for a heavy element like lead. It has no thermodynamic drive to gain more electrons and reach a lower oxidation state, which is not common for lead, nor does it easily lose electrons to become lead plus 4. Therefore, it is generally stable and non-oxidizing in stable conditions.